Thanks. No problem. All right, let me get to the start of my PowerPoint. Is it live?
Mm-hmm.
Are you observing chat?
How am I?
Are you just going to the channel?
Yeah.
Okay. I can go to the channel too on my phone. That way, this will give me some visibility.
Correct. Just make sure you turn the volume down so that it doesn't produce any feedback.
Gotcha. Volume is off. You had an hour for a screencast-a-thon. That's a long winter. I do not see the live lecture.
From fifth period,
No. I don't see the live.
go to videos.
Yep. Is it watched?
Yeah, it's live right now. It's the first thing that pops up.
Oh, that's so weird.
You see it now? Yeah, I got a student from my class that's in there.
Let me make sure I posted it, but I'm pretty sure I did. Remind me that I'm frozen.
Yeah.
Yeah, I have it posted today. Yeah, it's live on the. How many students are you expecting in this one?
I have, I think, 16 or so,
So
7
26.
periods, so you only have 10?
Yeah, I only have 10, so it's 26 for this one. Elsie Lynn, you have no mask. You need to move away from Mr. Evil. I know how to do this. Wait, actually, wait, hold on. Can you- How many we got?
7 so far.
You're a little bit over 25%. Alrighty guys, so we are going to wait a little bit longer to make sure that everyone has an opportunity to log in. I know this is a different protocol, especially if you have different classes that do different things. So we want to make sure to give everyone kind of an opportunity to get onto the YouTube channel. And so we're going to wait until about 2 o'clock until we start the ball rolling. Can you see who's in?
We got 8 so far.
Another thing you want to make sure to do is to make sure that you're logged into your Fort Thomas account. So if you're logged into your Fort Thomas account and joining this channel, we've had issues with people being able to join and chat. So you won't have any problems at all if you log into your Fort Thomas email address and you participate in that way today.
Yes, it is. No, ma'am. Yeah, I'm chatting to this on space. So I already did this student, but I'm still doing my yeah.
Alrighty guys, so let's go ahead and get started. I know that there are still some people that may or may not be logging into the channel. Not a big deal. We're going to go ahead and get started because we don't want to make sure that that we end so that you guys have an opportunity to answer questions. So what is science? Science is a method for studying the natural world for scientists. And being able to break down those particular questions that we have about the natural world and in such a way where we can come up to an answer using different types of strategies. Now, in terms of the process of observation and gaining knowledge, especially about events in nature, we can think of a very, very recent event that occurred, Hurricane Laura. We know that Hurricane Laura hit Louisiana. It was a Category 4 storm. It was massive. But before, how did they propose that hurricanes came to be? Well, there were gods, and that those gods created these hurricanes. So in Greek mythology, it was Poseidon. Now we know through the different types of energy that is stored in the oceans and the warmness of the ocean is really how we have hurricanes and how those hurricanes become stronger and stronger. Now, the scientific method is the way in which scientists break down that problem into its specific parts. So, In terms of the scientific method, we have 6 common steps, and we're going to give you a very, very easy way to remember all the different steps of the scientific method. Now, what I would like you to do is to go ahead and get out a sheet of paper. Okay, so a sheet of paper is something to write with. And what you're going to do is you're going to write down this as well as other questions that you're going to upload to Schoology later on. That's going to ensure your participation and also that you get points for that as well. So the 6 steps of the scientific method: ask a question, research, gather information, hypothesis, experiment, analyze data, and drawing conclusions. Now, this drawing conclusions could also include discussions as well as talking with your peers about your results. So what you're going to notice that the first letters of each one of the steps spells out RHEAD. So it's a very, very easy way to remember the 6 steps of the scientific method is RHEAD. Okay, so I'm going to give you guys a minute or two to write that down. Okay, so the first step to the scientific method is stating a problem or asking a question. So, Mr. Ewald, what's been going on the last 2 months?
There's been a little virus going around, I think.
Is the coronavirus still a thing?
Yeah, absolutely it is.
Okay. So we have the coronavirus here, and we have our anime figure. This is from Naruto, and you can see that this figure here is wearing a mask. Not only that, but he's wearing it appropriately. It's covering his nose and his mouth, and we know that the coronavirus spreads through water droplets when speaking. Now, you might be wondering, well, Mr. Wynn, why aren't you wearing a mask? Well, I'm doing the other guideline. I'm doing the 6 feet distance rule. So as long as I'm 6 feet away from other people, I do not have to wear a mask.
I'm Mr. Ewald. I do have a mask on, right? Wearing properly over my nose, over my mouth. We'll get back to Mr. Wayne. Good to see everybody.
So the first question I want you to make sure to answer is, what is the question we have about masks and the coronavirus? Okay, so you don't have to write the question down, just write the answer down. What is the question that we have about masks and the coronavirus? So I'm going to give you about 1 or 2 minutes to think about what that question is, and then we'll hear from the audience what that question is. Righty, as we are finishing up writing down what that question is, what I would like to do is to hear from the audience what those questions are. So if you're finished with your question, go ahead and type in the chat section on what you think that question is. Okay, and we'll get some responses from Mr. Ewald later on. Alrighty, Mr. Ewald, do we have any responses yet?
We do not have any yet.
Okay.
Still waiting.
So make sure you get those responses in about what that question is about masks and the coronavirus, because it's going to lead into what we're going to be doing today. Okay? So, question number 2, researching and gathering information. Now, we're going to run an experiment. But before we can do that, we're going to create a hypothesis. But before we can even do that, we've got to learn about the actual subject itself. Okay, so we've got to learn about the coronavirus. We know that in the past, about 1918, there was another virus that was very similar to the coronavirus, and that's the Spanish flu. Could we learn about the coronavirus using the Spanish flu as a model? Absolutely 100%. And what we're noticing is that social guidelines, all these different measures that we're taking in order to reduce the spread of the disease, is based off of what we saw with the 1918 Spanish flu. Okay? So, what I want you to do for question number 2, what are some resources we could use to look up information? So, what I would like you to do is come up with about 2 or 3 examples of those resources that we could use to look up information in order to make sure that that information helps us with our research. Okay. Now, and remember that we're still waiting on those responses for question 1, so if you had those responses, please let us know.
We stated here the first time. Let's ask a question. So what is the question we can ask about masks? Slow it down a little bit. Okay. So, Mr. Wen, we do have a question that just came in. So we did have somebody ask, are you asking about how we can stay safe during the pandemic? So that would be a question about what's something that we can use to stay safe during the pandemic. And then we have, what is it about masks that protect others or ourselves? And then one question could be, how effective are masks in preventing the spread of the coronavirus? Are masks really beneficial to protecting our own health as well as other people's healths?
Okay, so exactly what we're starting at. Go in that direction where we're looking at masks and the coronavirus. So back to question 1, absolutely 100%. If you said that we're looking at whether or not masks stop the spread of the coronavirus, you're absolutely right. Okay, so good job on that. So do masks stop the spread of the coronavirus? Because we know that there are some people out there that do not believe in masks, do not believe that masks work. And we also know that the coronavirus is transmitted through water droplets from our mouth. So every time that we breathe out, every time that we speak, we have the potential to spread water droplets. Okay, trying to speak to a person and not spitting on them. Okay, that's what you should do. But at the same time, some people have that issue where they're just spitting all over the place. So we want to make sure that we prevent that spread of the coronavirus through those water droplets. So then back to question 2. What are some resources we could use to look up information? So in other words, what could we use to look up information about the coronavirus, about any topic at all?
So as you're following along, if you see those questions pop up from me in the live chat, just go ahead and throw out some answers. Could be right, could be wrong. That's okay. Just throw them out there, and we'll see what we got. And as they come in, I'll kind of help out Mr. Wen by throwing out some of those answers that we're getting. So we have one already. The World Health Organization or the CDC would be a good resource.
Excellent resources.
We got another one for the CDC. Oh, we have your favorite, Wikipedia.
Oh, Wikipedia. We were going to talk about Wikipedia. So, Mr. Ewald, what do you think about Wikipedia? Is that a resource that we can use to look up information?
I would say that Wikipedia is most definitely a resource that we can use to look up information. Is it the best resource? Not exactly. Wikipedia does have citations in it. There are admins or people that watch the site to make sure that they're making edits and keeping the information as correct as possible. So it's a good starting point.
Okay, so in other words, they should not be found on your works cited page. Okay, so you can use it as kind of your stepping stone to other resources. Now, if we're thinking about other resources as well, so we can also come up with different types of periodicals, different types of journal articles. So you might have heard of National Geographic. They have a really, really big periodical. Nature is also another big periodical where they do some really good quality science. So all those different types of resources can be used in order to look up information. And by the way, all of this information about the coronavirus is coming out in those publications. So it's up-to-date information about what we know about the virus. Now, a hypothesis is the next step to the scientific method. So if we're looking at the scientific method as R head, we did A, which was ask questions. We did R, which was research. Now we're going to come up with the H, which is the hypothesis. So what is a hypothesis? It's a possible explanation for a problem, or in other words, a prediction of what you think might happen in an experiment. So from the picture on the right, can you hypothesize what Bill Nye was trying to solve? Okay, so we have Bill Nye in his mask. We have a candle. So Mr. Ewald, what do you think? What do you think he's trying to solve?
I think that by wearing that mask and standing over that candle, Bill Nye is going to try to answer the question of whether or not he can blow out that candle while wearing a mask.
Okay. So we have 4 different types of masks. What I want you to do is I want you to write down a hypothesis each one of these different masks. So what is a possible hypothesis for testing the efficacy of masks and a candle test? So efficacy, by the way, means how well it works. Okay? So in this case, this first one is a surgical mask. The second one is a mask that they sent us from KEA. This is a Holt Thomas mask, which we are going to replace with another type of mask that's similar. And we're also have this really popular mask, it's the Gator mask. Okay, so determine whether or not these masks are going to be good in terms of whether or not they're going to blow out the candle or not. So for this first one, and for a hypothesis, in order to write a hypothesis, all you would need to do is start with, I hypothesize that, and then your prediction. So it's a formal statement of what you think will happen. So you're going to start out with, I hypothesize that, and then for this one, it could possibly be, I hypothesize that mask number 1 will blow out the candle. Okay, it's just that simple, and making sure that you make that statement about what you think will happen. So I'm going to give you guys 2 minutes to come up with the different hypotheses for these different masks.
So go ahead and throw those into the live chat as you're thinking about them. What could be a possible hypothesis that you might actually write for testing the efficacy or how effective masks are with blowing out candles? So I hypothesize that, and then roll with it. See if you can put some of those in the chat, and we'll share them out. All right, so we have our first one. Thank you, Megan. Megan says, I hypothesize that mask number 4, so looking at the picture, mask number 4, will work the best for blowing out the candle.
Okay, so as you're finishing up writing these different hypotheses, what we're going to do is we're going to conduct the actual experiment to see whether or not these masks are going to work well. So, again, if it blows out the candle, is that mask good at stopping the spread of the coronavirus? That's what I want you to think about. Okay, and also think about the different type of masks that you also wear as well. Okay, so we have our candle, and we have our 4 masks. And what we're going to do is we're going to run the experiment. See, just to make sure that we are able to test the efficacy of these masks. So, the first thing, we want to make sure that this candle blows out. We want to make sure that we're testing whether or not masks work or not. So, Mr. Ewald, what's the first thing I have to do?
You got to try to blow that thing out without wearing a mask.
Yeah, because I don't know if this guy put a trick candle in here or not, so we got to make sure that this blows out. Because if it didn't blow out, there's really no point in doing this experiment at all. Okay, but we're going to test it. Okay, so we know that not wearing a mask will blow out the candle, and we also know that not wearing a mask will also spread that coronavirus in the water droplets. Okay, now, experiment number 1, or mask number 1. What I want you to do is just a simple yes or no. Okay, do you think that this mask will blow out the candle or not? Okay, so yes or no, do you think that this mask will blow out the candle or not? Okay, we have our responses, Mr. Ewald.
Not just yet. Let's give it just another moment. Go ahead and you can light the candle and we can get ready. And then we'll see. Our first response is no. And then we have a yes.
So just to recap, Mr. Ewald, is a yes good or bad?
Yes would be bad.
Okay, so yes would be bad.
So we're about 50-50. 50% yes, 50% no for the surgical mask.
Okay, so let's go ahead and see whether or not we can blow out this candle. Okay, so I'm going to keep this fairly close to me, and we're going to see. Okay, that was really close. Okay, that was really, really close. So it really depends on how far you are with this mask. I would still say that that's a no.
I would agree.
Okay, our fabric mask. Okay, so the ones that were sent by KA. Yes or no, mask number 2. Okay, yes or no, mask number 2. Okay, Mr. Ewald, do we have responses?
We do. It's looking a little bit 50-50 again. We got some no's, but we also have some yeses. So as these kind of come in, still 50-50.
Okay, let's see.
Uh-oh.
That's not good. All right, so these masks do not help to spread, do not prevent the spread of the coronavirus. So again, not all masks are the same. Not all masks are equal. So you want to make sure that the mask that you're wearing is good at stopping the spread of the virus. All right, this is the one that my wife bought from Findlay Market. Love this mask because I love Cardinals. I love Charlie Harper. What do you guys think? Mask number 3. Mr. Ewald, do we have results yet?
Not quite yet for that question. Our first one is a yes. Second one is a yes. We're heavy on the yeses so far, but we do have a couple that are saying no.
Okay.
So I think we're being swayed toward thinking that a lot of the masks we're going to be able to blow out the candle. So it looks like based on the answers from the students so far, they're thinking kind of overwhelmingly yes.
Okay, let's see.
Wow.
Okay. So again, I tried my best. I tried my best to blow it out. Mr. Ewald, is this a good mask?
I would say absolutely yes.
Got our values worked. All right, and the last one, the Gator. Okay, so this one is mask number 4. Yes or no?
So at first we were overwhelmingly, I would say, well, we still have quite a few yeses. We have a no chance in there. So somebody has a lot of confidence in the Gator mask. Right now, I would say primarily yeses. We do have a couple of no's, but I would say the majority right now are saying yes.
Okay, so let's give this a shot.
Oh, man.
So again, guys, really important. All masks are created equal. Make sure that the mask that you're wearing is effective. Gotta say it. We are professionals. Do not try this at home. Okay, so what we just did was perform an experiment. So it was a way to test these different hypotheses out, and whether you were right or wrong doesn't matter. Okay, what matters is the fact that you ran the experiment and you controlled certain conditions. And we're going to talk about those conditions, and we're going to talk about something called variables. Now, a variable is a quantity that can have more than a single value. So it's all these different factors that you take into account whenever you run an experiment. So let's take, for instance, an experiment about plants and fertilizers. We could set up an experiment about plants and fertilizers and have us look at those variables. But we can also change a lot of different things about plants. And we can change a lot of different things about their environment. So we can try out, we could change out the 3 different fertilizers. We could change out the plant type. We could change out the amount of sunlight, the amount of water, room temperature, type of soil, and type of fertilizer. But there are many other variables out there as well that you could possibly test for any experiment. So if you're looking at height, you're looking at weight, all of those are variables because they have more than one value. Not everyone is the same way. Not everyone's the same height. I'm short. Now, in terms of another variable that we have to talk about is the dependent variable. So it's the variable that we measure, or it's the variable that we collect data on. So in our experiment, or in our hypothetical situation about fertilizers and plants, we have to look at what we are measuring. So we're measuring height after 2 weeks. So in this case, we have to decide whether or not those fertilizers had an effect. Now, there are more than one way, or there are more than one way in order to measure one way to measure data. So it could be qualitative data or it could be quantitative data. Qualitative data is categorical data. So in other words, it could be the type of color, it could be something that happens, and it could be a simple yes or a no. Whereas quantitative data is continuous data. So in other words, it involves numbers. It involves preceding and also numbers that follow. So your height, your weight, the number of people in a room, all quantitative data. So Mr. Ewald, what do you think? In our experiment that we conducted, was that qualitative or quantitative data?
Well, we were looking for or recording whether or not you could blow out the candle while wearing different types of masks. So we were looking for basically a yes or no answer. We weren't calculating any values. We weren't taking down anything else other than yes or no. So I would say qualitative.
There also weren't any numbers involved as well. And so it, again, becomes very, very easy to be able to decide whether you're working with qualitative data or quantitative data. Now, in terms of another variable that we have to make sure that we look at is the independent variable. It's the variable that we change or that we physically manipulate. So in this case, we can physically manipulate, we can physically change the fertilizer type so that we have A, we have B, we have C, or we don't have any fertilizer at all. So this becomes our independent variable. And what you notice as well is that based off of this independent variable will give us an answer to this dependent variable. Now we want to make sure that the experiment that we run is due to just the fertilizer alone. So we have to have something called constants, or factors that do not change. So we know that for the amount of sun, plants need sun, we need to make sure that we keep that constant, we keep that the same among all the different plants. So every single one of these plants will receive 6 hours of sunlight a day. All these plants will receive 4 ounces of water every 3 days. And all the plants are the same. So in this case, we want to make sure that these constants do not affect what we're really testing for, which is the independent variable. And then lastly, the control. So the control is super important in making sure that there is an effect. So in this case, it's the standard of comparison, and it does not receive any of the independent variables. So in this case, it's going to be plant number 4. That's your control because it doesn't have any fertilizer in it. So what does that mean? That means that we can compare a plant that doesn't receive any fertilizer with ones that actually receive the fertilizer to see whether or not there's an effect. Because there is a possibility that not adding any fertilizer could be exactly the same as adding fertilizer. So you want to make sure that you take that into account. So you would compare number 4 with number 3. You would compare number 4 to number 2, and you would compare number 4 to number 1 to make sure that the fertilizers have an effect. Now, for question number 4, and what I want you guys to write down, what is the dependent variable in our experiment? So in other words, what was the dependent variable that we measured with our mask experiment? So I'm going to give you guys about a minute to think about it, write it down. And again, if you know the answer, let's hear it in chat.
So in that live chat, again, go ahead and add in there, what do you think the dependent variable was in our mask experiment? Dependent variable. So we do have an answer here, and she included both dependent and independent, but we'll just look at the dependent. So we had dependent, the candle being blown out. We had another one, was the candle blown out? Will the candle be blown out? Dependent flame being blown out or not. So far, spot on with the answers for the dependent variable, whether or not the candle blows out.
Excellent.
So
guys.
fantastic.
Good job. That's exactly what we're looking for in terms of the dependent variable and what we measure. Question number 5, what was the independent variable? So in other words, what did we change? I'll give you guys about a minute to think about that. And again, if you know the answer, put it in chat.
So great job with those answers, guys. Perfect with knowing what that dependent variable is. So go ahead and add in also, what did you think the independent variable was in our mask experiment? So we already have them coming in. The type of mask, the type of mask, the type of mask. So again, we are spot on. What mask was worn?
Awesome job, guys. Okay, and again, not all masks are created equal, so you got to make sure that you pick the right one. All right, question number 6. What is the control in our experiment? So in other words, which one did not have the independent variable? Okay, so what is the control in our experiment? In other words, which one did not have the independent variable? And remember that we are now on question number 6. Okay, so make sure that you're writing these different questions, these different answers down.
And just to add in there, guys, if you're not answering them in the chat, make sure that in your own notes or on your discussion board, whatever it is that you're doing, make sure that you are writing these answers down. So what was that control in the mask experiment? We have 2 answers, 3 answers. When no mask was used, when no mask was worn, no mask being used. So,
excellent job, guys. Oh my goodness. All right, so absolutely 100% it was whenever I did not have a mask on. What is the constant in this experiment? In other words, what didn't change throughout the experiment? Now, there's going to be a lot of different answers for this, okay? So feel free to put down a couple of them. Make sure to put them in chat. Make sure to write them down.
So we'll give it a second here as they're coming through. We have 1, the type of candle used.
Nice.
Most definitely would be a constant. You want to use the same type of candle every time. The first 3 are all about the candle. We got one in there about the guy blowing out the candle.
I like it. By the way, the guy's name is Mr. Wynn. Appreciate that. But you're right.
Somebody did put that in there in another one. So we have the candle type, the person performing the experiment. So far, so good. Ooh, the candle was the same. You used the same lighter. The same person conducted the experiment. So now we're really starting to dig into what are those things that we kept the same throughout the entire experiment from trial to trial.
Absolutely. And not only that, but could we run this experiment again? And could we run this experiment with a different person? Absolutely 100% you can run it with a different person, but they then become the constant themselves. So you want to make sure to keep the same person if you were to do the same exact experiment. All right, so in our head, we are on the second A now. So that is you're analyzing the data. So in this case, scientists need to be able to convey the information in a very easy to read model. So in this case, it could be a table, it could be a graph, or it could be a chart. So we know through all our different classes that we've taken before that we've seen tables, we've seen a bar graph, a line graph, we've seen pie charts, and they're visuals in order to help the audience understand what the researcher wants them to know. So that's what I want you to do for question 8. I want you to create a chart. So what you're going to do is you're going to create this chart here where it says type of mask, results of the candle test, and you're showing the efficacy of the masks. Now, if you don't remember the masks, that's okay. This is going to be mask number 1, mask number 2, mask number 3, or mask number 4. And if you don't remember what the masks were, this was the surgical mask. This was the fabric mask. This was the fabric mask that my wife had purchased. And this is the gator mask. Okay. Now, just to kind of help you out, Mr. Ewald, what would you put in this section, the results of the candle test? What would you put down?
So that would be our qualitative data. So we would either say, yes, the candle was blown out, or no, the candle was not blown out.
Okay, so I'm going to give you guys a few minutes in order to make sure to write that down. Use the universal sign. So you might have any questions about what we've been talking about today? Do you have any questions at all? Please let us know. It's a great opportunity during NTI to be able to ask these questions and for us to be able to answer them. Not only that, multiple teachers makes this a really worthwhile experience. So, again, if you have any questions, please let us know. Alrighty, guys. And so the last step to the scientific method is going to be drawing your conclusions. So here's where you're going to look back at your hypothesis and decide whether or not that prediction was correct or not, whether or not your hypothesis was supported. So in this case, whenever we're talking about our hypotheses, it doesn't really matter whether they were right or wrong. You're not going to be penalized for having the wrong hypothesis. So please don't think that. A wrong hypothesis helps us to be able to form a future experiment. So even a wrong hypothesis can be correct. So, question number 9. Was your original hypothesis supported? So what you're going to do is you're going to look back at your original hypotheses, you're going to review them, and you're going to make a very simple statement. No, my original hypothesis was or was not supported. The mask was or was not able to blow out the candle. Or it could be, yes, my original hypothesis was supported. The mask was able to blow out the candle. So again, looking back at those original hypotheses and making sure that you write a review to that hypothesis. Okay, guys, just again to make sure that you have any questions, make sure to slot any questions into the chat so that we're able to answer them. If there's something that's really confusing, I know we went over a lot of different scientific terms like dependent variable, independent variable, constant, control. We went through all these different terms. If there's something that you don't understand, please let us know, and that way we can answer those questions.
We did have, just to interrupt you real quick, we had one response on the live chat. There may be some coming here in a minute, but it says my original hypothesis was supported by the experiment in test 1 where a surgical mask was used, the flame was not blown out. Just a fantastic statement as a conclusion for the experiment. Then we had my original hypothesis was not supported, the surgical mask was not able to blow out the candle. So, looking good.
All right, very good. And good job, guys. Okay, so the last thing is to make sure to turn in these questions by the end of your class period. So I know that I have an assignment for my students that I'm going to publish in Schoology here after this talk is over. So check Schoology, make sure you understand the instructions on how to submit it. But for me, take a picture, upload it, you'll get your points. Next is going to be check Schoology to see whether or not your teacher has assigned any more work. I'm going to assign some independent work for a scientific method that is due on Thursday. So, in other words, I'm giving it to you early so you have an opportunity to work on it, fit it within your schedule to make sure that you can focus on other classes if you need to. Okay? And then our next time-bound event will be in small groups or individually. So, I went ahead and I made the small groups for my class. So if you are not in a small group in my class, please make sure to let me know. I don't want anybody to feel left out. Okay, so again, check with your teacher, make sure to submit the work, and that your next time-bound event will be in small groups or individually.
All right, now I'm going to jump in here really quickly. Mr. Wen moved 6 feet away so I can take my mask off. We have a discussion board that is live on Schoology, so you can go ahead and take what you did, what you wrote down during the lecture, and you can put that into Schoology and submit that. That will be your participation for this part of the day. I also have a practice for the scientific method that is posted on Schoology. It is also due on Thursday, so you have a little bit of time to complete that. When you do complete it, just go ahead and submit it. That will be open and ready for you. And then I'll be reaching out to you guys to let you know about our time-bound event for Thursday. You guys rock. Fantastic job. Thank you for participating, for being a part of this today. We're just trying to make it a little bit more like an actual school day, even though we're talking to you through a camera and we're doing all of this through the computer. But you guys are fantastic. You did an awesome job. So thank you so much. We'll see you on Thursday.